So relative humidity. So what is it? This is probably the most common parameter, and it's probably the most common because we can feel it. We can feel changes in relative humidity. And maybe it's also most common because we hear about it on the weather report. Usually the weather people will say the humidity is such and such, and what they mean is relative humidity. So relative humidity is actually just a ratio of the amount of water vapor compared to the total that could be present based on the temperature. So the bucket analogy, I think, is a good one. Say you have a 1 gallon bucket and you've got 1 gallon of water. So right now this bucket is at 100% fill. Then you move over and you same amount of water, which would be similar to saying it's the same PW, or the same water vapor. Now you increase the bucket size to 5 gallons, and now you're at 20% fill. So this would be like if you took a certain temperature, and then you raise the temperature, you increase the bucket size. So by raising the temperature, you go from 100% to 20%. And if you raise the temperature more or increase the bucket size more, now you're at 10%. And we'll see here in a couple of slides that relative humidity goes down as you increase the temperature. So in this case, PWS changes as you change the temperature, and so the relative amount of fill changes. It's mathematically, it's just a ratio, PW divided by PWS. So in this case, PWS was like our bucket size, and PW would be the amount of water. So if you have a point here, oops, on the chart, this point here, you've got a PW measured at 200 and a PWS at 480. So we go up here and across. So your relative humidity is 42%. But again, it's important to note that as the temperature changes, PWS here changes. So if you don't have a stable, if your sensor is measuring relative humidity and you don't have a stable temperature, this keeps changing. And if this keeps changing, your measurement is going to be off. And we'll talk a lot more about that in the best practices section. So let's look at an example. Say we have this point here, 60 degrees C. We've got a measured amount of 70 millibars for PW. We have 200 for PWS. And we're going to take this air, we're going to heat it up to from 60 degrees to 90 degrees. So let's see what happens to it. So what happens to PW? Any changes there? PW doesn't change because we haven't changed the pressure and we haven't changed the amount of water vapor. Then what happens to PWS? What's your new PWS? I'm going to take a guess. Goes up. Let's take a ballpark. You go up here. You go across. About 700, 750. I said 700. So our RH goes down to 10%. So it went from 42% to 10%. It got quite a bit drier, relatively speaking. How about the same point? Now we're going to cool the air. We go from 60 degrees to 40 degrees. So what's our PW? Still doesn't change, right? Still 70. What's our PWS, would you say, here? Yeah, it's probably about, I'd say it's 70. It's on the saturation curve, so it's probably 70. So our RH is 100%. So as we continue to go down, cool the temperature, wherever we are here, when we cool the temperature, as soon as we hit the saturation curve, we get condensation because there's no more capacity.
More moisture than the saturation pressure temporarily?
Say, I'm sorry?
What I mean is, can relative humidity go beyond the 100%
Oh.
short period of time?
Well, the question was, can relative humidity go above 100%? Yeah, it can. Yeah, it's beyond the scope of this class. But yeah, you can get supersaturated conditions. I think it's mostly in the upper atmosphere. Anyone know about supersaturated conditions? Have it on the East Coast? I think I'm feeling it here a little bit. Okay. So a rule of thumb for relative humidity and temperature, as you increase temperature of any system, the relative humidity will go down, and you'll get drier conditions. As you decrease the temperature of any system, the relative humidity will increase, and you'll become more moist. A good example of this is in most cities, but I'll give example of in my office in Louisville. So in the wintertime, the indoor humidity in my office, which, by the way, I can measure because I have instruments in my office, I measure it at sometimes 7%. 7% RH is very dry. But what's happening there, and it happens every place, is in the wintertime you've got, say, 40 degrees outside, you're at 40% RH. You bring that air in, you heat it up, and obviously you're going to get drier because of this rule. So it's a good rule of thumb for troubleshooting. If you're out in the warehouse or out on the plant floor, you're getting condensation and you're trying to decide how, if I change the temperature, or maybe the temperature was adjusted and now you're getting some problems, you can kind of have a rule of thumb there. How about pressure and relative humidity? Does pressure affect relative humidity? The answer is yes. And again, we're talking about if we were to take this air right here, and we were to change the pressure of this air, it'll change the relative humidity. And if we remember Dalton's law says PT equals PW plus P dry. So if we look at it mathematically, say for example, we double the pressure. We double the total pressure. That means each of the gases' pressure also doubles. So PW will increase. It changes proportionately. So say we have a point here where at 200 millibars for PW, 500 for PWS, and 40% RH. We're going to double the pressure of this system from 1,000 millibars to 2,000 millibars. So let's see what happens to this air. So what happens to PW? It goes from 200, does it change? Goes to 400. So PW is 400. PWS hasn't changed because we haven't changed the temperature. So PWS is still 500. So our RH went from 40% to 80%. And if we were to continue to increase the pressure, we would again reach saturation, and we would have condensation. This is important in compressed air systems. How many of you guys deal with compressed air systems? A few? Okay, good. So, you know, the guys out on the plant floor always want more pressure, right? They always do. And so if they ask, they're getting 80 psi and they want 100 psi. So they go to the compressor manager and say, I need more pressure. And so the compressor plant manager should know that, well, if I increase my pressure from 80 to 100, well, that 20 psi difference is going to move me closer to saturation. Depending on how dry the air is to begin with, you may or may not get water in the air lines from that change. But you need to know that increasing pressure approaches saturation.